It's recorded already, right? I think last week I've recorded, but then suddenly when we finish the lecture, we cannot see. We cannot find the. I cannot find the video, so I don't know what happened. But I'm sure I have recorded the session last week. Sorry.
It's in the comment section.
Oh, you found it.
Mm.
Oh, okay. How come I cannot find it? Okay, it's okay. Okay, let's get back to the slide. Can see my slide, right?
Yes, sir.
Okay, right. Okay, so before we start with today's topic, actually today's topic is a continuation from last week. Still on air conditioning. Last week we have learned about mechanical ventilation and air conditioning system. So system as a whole, I mean the basic principles of basic cooling principles of air conditioning system, and you have learned about two types of aircon system, which is the room air conditioner or the window unit, as well as the split system. So this for today is going to be another two types of air conditioning system, which is package and plant system. So last week, basically the system is normally used for small building and for a room. But today, the system that you're going to learn is more suitable for larger buildings, okay, for a whole development complex or for a large building like multi-story building, okay, high-rise building, and so on. Okay, but before that, like I mentioned, let's do some revision. So you can go to www.menti.com and use the code shown in the screen, 90020456. Okay, that's not my phone number. Okay. Okay, go to www.menti.com and use the code 90020456. Let me open it. Where's it? Okay, you can see people start coming in. Okay, students start coming in. But only 9, 10, 11. The profiles are cute, very cute. Okay, let's look at the first question. Okay, which of the following components absorb heat and produces the cooling effect in air conditioning system? Don't wait to see your friends answer. Okay, it's actually the evaporator. The one that absorbs heat is the evaporator, and basically when you turn on the aircon, the air is blown over the evaporator and gets into the room. So basically the evaporator is the cooling coil. The other word for evaporator is the cooling coil. So it produces the cooling effect. At the same time, it absorbs heat from the space. Okay, second one. Just two questions. Okay. Okay, ready? I think this one is easier, much more easier. Which of the following is not a component of mechanical ventilation system? Fire damper, fan, ductwork, compressor, diffuser. Okay, right? So basically, yeah, I'm surprised a lot of you answered fire damper, but actually fire damper is part of the mechanical ventilation component. It's one component in mechanical ventilation system, which is placed inside the ductwork, right, to prevent fire from spreading from one room to another. So the correct answer here is compressor, which is the component for the air conditioning system. So it's not under mechanical ventilation system. Even though in air conditioning system there is also mechanical ventilation system is part of the air conditioning system, but compressor is not considered as mechanical ventilation system component. All right. Okay, but that's all for the menti.com. Okay, basically for the free version, I only allowed to have only two questions, two slides. Okay.
Study.
Yeah.
There's no music ke for Menti?
Oh, I never tried. Boleh kot?
Yeah.
You normally use Kahoot, right?
Yeah, usually we use Kahoot. Kahoot got that
okay.
catchy music.
Alright. Next time we'll try that. Okay, so now let's go to the lecture for today. Okay, the first system that we're going to learn today is package unit air conditioning system. Okay, so let's look at it. Okay, so last week I've already mentioned that it's actually very important to you for you to understand how the refrigeration system, how the air conditioning works, and the basic principles of air conditioning system, how they work, and what are the components. Okay, so if you can recall last week, the main components for air conditioning system is basically the condenser, compressor, evaporator, okay, and then pipes to connect between the evaporator and the condenser, things like that. So basically, all these components are actually similar in all the different air conditioning system. Okay, doesn't matter whether it's a window unit, a split unit, this package unit, or plant system. Basically, the components are similar. It's just that maybe the size is different, and also the name of the component might be slightly different. For example, like in the larger air conditioning system, which I'm going to cover next, instead of using condenser, okay. So in the larger system, they use like chiller, okay. So things like that, right? But the principles are the same. So there would be the cooling coil, okay. So in the smaller version, we call it evaporator, and then the not heating coil, basically the coil that releases heat into the atmosphere. Okay, in a larger system, they call it differently, you know. Okay, so for package unit air conditioning system, the concept is very much similar to the window unit. So if you still remember window unit, so all these components, air conditioning components, is packaged in one unit, right? But for split unit is slightly different because it is divided into two parts, the indoor part and outdoor part. So basically, you have two units. But for room air conditioner, as well as this package air conditioning system, the components are placed in one unit. Okay, it's just that the size is different, and maybe the way it distributes the air into the room is slightly different. Okay, so this kind of air conditioning system, this package unit is used for medium-sized building or rooms. For example, the whole house, halls, large restaurant, and so on. Okay, compared to the window unit, it's only used for one room, one small room. Okay, but for this package unit, it is used for this one unit can serve for the whole house. Okay. Like I mentioned, all the important components are enclosed in a single casing. So if you look at this section, this cross section of the package unit, you can see all the components. the blower. Blower is basically the fan. So the one on the left is basically the part that produces the cooling effect, and the one on the right, okay, basically the part that releases the heat, okay, to the atmosphere. You can see the compressor, the condenser coil, and then condenser fan, right? Similar to the window unit, there are two fans. One is for the condenser. Another one is the blower to blow the cool air into the rooms, right? But what you cannot see here, but what the label, there's one label missing here, is basically the evaporator coil, which is you can see like this black or gray colored thing at the back of the blower. Okay, basically, this part is the evaporator. And you can see that the position of this package unit on the rooftop. Right? But in Malaysia, I don't think it's common to see this kind of air conditioning system, but it's more suitable, or not to say suitable, it's more popular overseas, right? Okay, so this is a closer look of the components in the package unit. So you can see just now it's just showing the main component inside the package unit, but in this diagram you can see how the package unit connects to the ductworks, okay, and then into the spaces. So you can see the this is the package unit. Right. Sorry. Right, so you can see that this is the package unit with the compressor, okay, condenser, evaporator somewhere here, filter. Okay, I think somewhere else, there's somewhere there is the expansion valve, right? The one that controls the amount of the liquid refrigerant. And then okay, you can see here the supply air fan. Okay, basically this is the one that blows. So basically what happened when you turn on the aircon, right? So this is, if you still remember, this kind of fan is it is called the centrifugal fan. Okay, so the direction of the air coming into the fan is 90 degrees, if you still remember. So the fan blows to the bottom. Okay, so it blows down to the ductworks, right? But it gets the air actually gets into the fan from this side, okay, from the left side. It gets into the fan, and then 90 degrees it goes down to the ductwork. So as the air enters the package unit, it basically get filtered. Okay, the fresh air from outside, like I mentioned, not so fresh, it's kind of polluted also, right? With the smoke and other pollutants. So it gets filtered. And then it actually passes through the evaporator, which is the cooling coil, and then it become cool, and the cool air is basically blown through the ductwork and into the rooms. Okay, at the same time, the room beneath the ceiling, below the ceiling, the room, the existing air inside the room gets sucked into this return air grill, right? So it gets up here again. Because there's a fan here, basically some air is actually is pulled through the return air grill and gets into the filter, and again, so it basically recycled. So at the same time, you get fresh air from outside, as well as the recycled air from the room. Okay, they get mixed up and then filtered and blown over again to the room. Okay, at the same time, the refrigerant inside this system, okay, basically flows from the evaporator to the condenser, back and forth, right? So as it gets to the condenser, okay, the heat from the refrigerant is released, okay, into the atmosphere through the condenser fan. So basically the condenser fan, when it rotates, it pulls air from the outside, right? It pulls air from the outside here, and then it passes through the condenser, and then the heat is carried out from the top. Right? So basically the heat is released from the top. It gets from the side, and then it released from the top. And there you can see the control panel. I believe this control panel should be inside the room now. It's not inside the ceiling. So you can imagine that this whole thing is inside a ceiling space, or maybe if you use a flat roof, right? So maybe this package unit is placed on a flat roof, okay? But this control panel should be inside the room. So who wants to control the aircon from the ceiling space, right? Right, so this package unit can be installed at the rooftop. There are a few places that you can install this package unit. That you can install on the rooftop, on the ground, inside a ceiling space, or inside a closet. Okay, depending on the variants lah. So there are two different. There will be some variant in this package unit as well. So the normal one would be like this lah. So you have a building and then just put next to the building, just like the split system where you put the outdoor unit outside the house. But for split system, maybe because the size of the condenser, the size of the outdoor unit is quite small, okay? So it doesn't consume much space outside. So if you don't have much space outside, maybe this kind of placement is not so suitable. Okay, and then for for houses overseas, right? They normally have this kind of floor level, so they have like this. Sometimes they have basement, things like that, to put the air conditioning equipment, to put the utilities, spoiler, and so on. So the ductwork can comes from underneath the floor. Okay. But in normal building, maybe you can put the package unit on the rooftop, especially if you have a flat roof. It's easier to put the package unit on the rooftop. But as you can see from this image here, even if you have a pitch roof, you can put it on the rooftop, but then you need to have like a dedicated space on the rooftop where you can place the package unit. Or you need to use some kind of bracket that suits the pitch of the roof to put the package unit. Right. So ducted type require ducting for the distribution of air of the conditioned air. Okay. So basically from the package unit, you connect the ductwork, and then and you deliver, or you direct the cool air to the spaces. Okay, so as you can see from the section, from these two sections, you have like the diffuser that supply cool air, and also you can see the grill for air to return back to the package unit. Right, as I mentioned earlier, so the air from inside the room is some of the air is actually recycled, okay? Recycled, filtered, everything, and then it is transferred back to the room. Okay, ductless type. So here you can see two different types. So one is ducted type. Ducted type means that you use ducting. And then another one is ductless type, where you don't use ducting. So this one is slightly different. It does not require ducting, and the conditioned air is supplied directly from the diffuser located at the top of the unit. So all the diagram that you can see here basically is using the ducted type. Anyone want to say anything? Okay, so there's another type which I'm going to show later, which does not require ducting, which looks slightly different from this. There are two methods of removing the indoor heat in the larger package unit. First one is air cool, and the second one is water cool. Right, so the air cool is basically where the indoor heat is removed by the outdoor air. So this is the one that I've shown from the earlier slides. So equipment are located outside the building, adjacent to the room to be air conditioned, or on the rooftop for easy flow of air. So what it means here is okay. We use the air is used to cool the condenser. Okay, so this is the condenser. And then the top part, as you can see from the diagram earlier, this is the condenser fan. So as the aircon is turned on, the condenser fan would actually suck in the air from the side. Okay, from this side, okay, it gets into the package unit, and it actually passes through the condenser coil, right? And then it will carry the heat from the condenser coil and goes up and release it to the atmosphere. So basically, in this system, air is used to cool the condenser. Okay, just the outdoor air. So basically, the fan suck in the outdoor air, and then the outdoor air carries the heat from the condenser and then release back to the atmosphere. All right. So how can you identify whether this is air cool or water cool? Basically, for air cool, it is not connected to any other component. Okay, so just the package unit itself, and then you see the blower, that I mean the ductwork, right? Okay, so this is another diagram showing how the system works. So when you have the package unit outside, right, and then the cool air is supplied into the room through maybe underneath the floor and underneath the ceiling, right? And then at the same time, you have a return air duct. So this is from this space over here. You can only see the grill, you don't see the ductwork. Okay. So the ductwork here, probably this is utility room where you can see the ductwork. But in other spaces, you don't see the ductwork. Obviously, basically it's hidden behind the wall or underneath the ceiling. Okay, so at the same time, you can see the return air grill. So the existing air gets into this return air grill and gets back to this package system, right? Okay, so another type is water cool. So water cool package unit. So the indoor heat is removed by continuous supply of water from cooling tower and etc. Meaning that there is another component which is the cooling tower, or maybe a component connected to this package unit. Right? So this is the one that we call ductless type. So ductless type, where so there are two kind of system that can be used. There are two type of package unit that can be used for this water cool, which is ductless type and ducted type. So ducted type, you can see the section here, right? Basically, there's a compressor and there is a water cool condenser, meaning that instead of using fan to draw in outside air into the package unit, so there is no fan. You don't see any fan at the bottom here. So just the compressor. And then you can see the water cool condenser on this side, right? So slightly different. So there's no fan. Okay. So this water cool condenser is actually connected to this cooling tower, as mentioned here. But on top, at the top of the component, of the package unit, it's basically more or less similar. So you can see the blower, and then you can see this is the evaporator coil or the cooling coil. So basically, the air from inside the room, right, is drawn into this package unit, and then it passes through the evaporator coil, okay, and then it gets to the this ductwork. So basically, this is the centrifugal fan that blows cool air into the room. So basically, this top part here is connected to the ductwork. So this is for ducted type. So for ductless type, you just imagine that the bottom part here, okay, the bottom part of the this package unit is similar to this. There's only compressor and water cool condenser. But the top part, okay, starting from here, this grill here and to the top, you can, if you look at this section, it's actually this part. So the indoor air is drawn from this grill here, right? And then it releases, this package unit releases back the conditioned air into the room. So the cycle is just like that. So it gets from here, okay, it gets conditioned, it gets filtered, it gets cool, and then it's blown from this diffuser on top. Okay, but for the ductless, for the ductwork, ducted type, it gets from the front part, and then it gets blown through the ductwork. So that's just the difference. So inside the unit, they are both the same. It's just that how the air is transferred or distributed into the room, whether using duct or not using duct. Okay, that's the difference between ducted and ductless. But the difference between water cool and air cool. So water cool, you don't need to have condenser fan to blow over the to blow the outdoor air over the condenser cord, but it uses water to cool the condenser. Basic refrigeration component are built into a compact indoor unit. Okay, so the difference, another difference between this two systems, air cool and water cool. Air cool, because it needs outdoor air to cool the condenser, so it has to be placed outside the building. Doesn't matter whether it's rooftop or on the ground or anywhere, but it has to be outside. But for water cool, because you don't need air to cool the condenser down, so it can be built inside the space itself. So maybe you have like a closet or something, you can place this air conditioning unit inside the house. Right, so maybe it looks maybe it can look nicer because you don't see like a bulky aircon equipment outside the house. Okay, but there's pros and cons in this system. All right, so basically that's all for the package unit. It's quite simple and quite straightforward. Okay, so now let's look at the bigger unit, bigger system, which is the plant system. Okay. Okay, so this plant system is normally used for either a very one single large building. Okay? It can be used in a single building, but the building is large, or you can use it in a complex, in a development complex where you have multiple blocks. You have several blocks in one development. For example, like hospital. Okay, in hospitals, basically, you know that you have normally it depends lah. Some hospital only have one block, but some hospital, especially the government hospital, there are few blocks. Okay, a few blocks to cater for different departments. And then hotels, okay, again, some hotels has only one block, and other hotels have multiple blocks. Office towers, airport, shopping malls, and so on. Right. A building can be wholly or partially air conditioned. So when you opt for this plant system, it doesn't mean that you need to air condition the whole building. You need to air condition every space in the building, right? So it's not necessary. So again, you choose which room that requires air conditioning system, right? So maybe basically it's as simple as introducing or equipping the spaces with ductworks. So if you want the space to be air conditioned, so you just connect the ducting to the space. So if not, then maybe you don't have to connect the ductwork to the spaces. So the spaces can be ventilated naturally, right? So the main components of this system are refrigeration plant. Okay, so as I mentioned, the basic components are the same: condenser, compressor, whatever, evaporator, whatever, and all these things for the plant system. All these things are located inside the refrigeration plant. Okay, refrigeration plant. So this is where the cooling effect is produced, right? And then the heat from the space is released. Okay, so this is done in the refrigeration plant. But for plant system, you have two other main components, which is the air handling unit or AHU and cooling tower. So I believe like this AHU normally it's just it's located in a room. Maybe some of you have came across this sign on the door saying AHU room, right? So especially maybe when you went to the shopping mall, okay, you want to go to the toilet. So normally this issue room is located at around that place, the service zone, service area. Okay, so in this system, the plant system, refrigerant is cooled in the plant room and distributed to the issue located in different zone. Okay, so basically the plant room is located somewhere else, and then the issue is located somewhere else as well, right? And in one building, you can have multiple issue. So not just only you should have only one plant room, but you can have multiple issue to serve different zones. Okay, so if you only use one issue, then I don't think it's actually suitable for you to use this plant system. I might as well use the package unit, right, smaller version, because if you have only one zone, you only want to cool one zone, then I think probably the space to be air conditioned is not big enough, so you don't actually need to use this plant system. So normally for plant system, you would have multiple AHU. You have a number of AHU rooms located at different zone. So this zone here means it can be a group of floor. So meaning that, for example, 2 floors can be regarded as one zone. Okay, so maybe for that 2 floors is served by one AHU, and then another 2 floor, so it's considered as another zone, so it is served by another AHU. So this is especially true for multi-story buildings. Now you have many levels, and then you can have several floors as a zone. But if the building is not tall, but it is large, it is sprawl on the ground, right? So it's large, but it's not tall, maybe just 3 or 4 stories, but it's quite large in the, it's quite wide. For example, like shopping complex. So normally shopping complexes are not that high, right? So it's not that tall, but it is large compared to high-rise building. So for this kind of building, for a large building like this, the zone can be in terms of the wings. Okay, some shopping complexes, there are wings, right, to mark different section or different zone. Okay, right? You have the north wing, south wing, east and west. So each of these wings can be considered as one zone, and even though there are different wings, and then for each level of the wings also, you can have multiple issue as well, right? So basically there are many variety of how you can introduce this issue in the large space, in large building. Okay, and then the treated and cool air is applied from the issue to the room in the same zone via the ducts. Okay, so basically what happened in the AHU room, so the AHU room actually consists of fan. So later on, I'm going to show you how AHU, what's inside AHU room. Okay, so basically the cool air is supplied from the AHU room to the spaces. So it's not supplied directly from the plant room, but from the AHU room to the spaces. Okay. So usually the system is installed during the construction of a building and should be integrated with the structure and spaces of a building in the early stage of design. So this is where the role of an architect is quite important, especially for this kind of air conditioning system, because you need to integrate, you need to incorporate the components, the plant room. You need to arrange where to put the plant room, where to put the issue room, so that it doesn't interfere with your design. Okay, so that's why zoning is very important in design. So I'm sure you have learned about zoning, right, in design, service zone, okay, public, private, that kind of thing. So normally this kind of thing, right, related to services is grouped under that service zone. So if possible, all the piping, all the this issue rooms, everything should be located at the service zone. So it's different with the other air conditioning system that you have learned previously. So those systems can be installed later on. Okay, you can build a house first. Maybe during the time when you design the house, you don't think that the client want to use aircon, right? But then later on, or maybe at first the client say, oh, I don't want to use aircon, I just want to use natural ventilation. Okay, so I'm a green person, so I don't want to use aircon. But then after a while, maybe after a year or two, then the client wants to install air conditioning system. It can be done. So for the smaller air conditioning system, even for the package unit, right? So you can install later on. So after the building has been constructed, after the building has been completed, you want to install the aircon, possible. But then, as I mentioned last week, it would have maybe it would spoil the look of the building. So you have already designed a very nice facade of the building, and then suddenly, after 1 year, after 2 years, the client wants to install aircon, then it actually spoil the nice facade that you have designed. So if possible, you need to incorporate the other air conditioning system at the early stage as well. Okay, but it's not really necessary lah. So maybe you just need to think ahead of the client's requirement. So, but for the package for the plant system, yes, you need to include this in your design right from the start, right? You cannot suddenly after the building completed, or then you want to add a plant room, but you don't have space anymore because the plant room is huge. Okay, you cannot simply sacrifice whatever room you have on the ground, or if let's say your design has a pitch roof, you cannot simply put the plant room on the rooftop. Okay, because it requires a flat flat surface. Okay, so that's why it has to be incorporated right from the early stage of the design. Right, so from this diagram, you can see the connection between. Just want to show the connection between the different refrigeration component. Okay, the component that produces the cooling effect, and the component that releases the heat, right, which is the refrigeration plant, AHU, and the cooling tower. So later on, I'm going to show you where you can actually place the refrigeration plant. This is just one of the example. So the refrigeration plant can be placed inside a basement. Okay, so inside a basement, you can put the chiller. Basically, what's inside the refrigeration plant is the chiller. Okay, this is the chiller. One is as a chiller or condenser. Condenser. Another one is chiller or evaporator. Okay, chiller is another name for evaporator. Okay, so and then as you can see from the evaporator, so remember I mentioned evaporator is the part that produces the cooling effect, right? So this pipe, the cool pipe, right? The cool pipe here is connected to the AHU. Okay, so if let's say you treat each level as a different zone, so this is zone number 1, AHU 1, AHU 2, AHU 3, and then from this AHU, the cool air will be distributed inside the all the spaces at the same level, right? But what happened is basically the chiller or the evaporator, right? There's what we call as chill water system. So chill water system consists of chill water supply pipe and chill water return pipe, right? So one supplies the cold water to the AHU, another one returns the not so cold but it's not hot, but it's not so cold. It returns back the water to the evaporator and then to be transferred to the cooling tower, right? So basically what happened here, so from the evaporator, the chill water supply. So if you, I think probably some of you have noticed when you look at the pipe. I think in tailors also you can see lah. So if you look up on the ceiling, you can see the pipe labeled as CHWS. CH means chill. Chill. W is water. S is supply. CHWS is chill water supply. So it supplies chill water to the AHU. And then at the same time, this light blue pipe, the name is chill water return, CHWR. Okay, so it returns the chill water, which is not chill anymore, right? Maybe it's just warm water. It returns back to this evaporator, and then it gets to this condenser here. Okay, so from this condenser, the water is actually transferred to the cooling tower. So if you look at this thick red line, basically it represents that the water at this point is quite hot lah. It's hot compared to the one with the lighter red. So the hot water is delivered to the cooling tower. So inside the cooling tower, the water, okay, so the water, it gets cooled down, and then the one that has been cooled down is the light red color, is pumped back to the chiller, okay, and then in the chiller it's get chilled. Yeah? Okay, there's a compressor, everything, so it's get chilled. Then it is distributed back to the AHU. Okay, so this is the connection between the system mentioned earlier, the plant room, cooling tower, and the AHU. And on top of that, you can see the ductworks. Okay, and basically the dotted lines indicate the pipes. So I drew that myself. Okay, earlier you have looked at the in some system now, especially overseas, they have boiler, or maybe in Malaysia also in some certain kind of building that they have a boiler. But for this subject, you only need to learn the refrigerant. I mean the refrigeration system. Okay, so you can see the chiller, and then as I mentioned, so the chiller actually supply chill water to the AHU, right? So and then from the AHU it returns back to the chiller, and then from the chiller it gets to the cooling tower. The hot water gets into the cooling tower, it gets cooled down, and then goes back to the chiller, then transferred back to the AHU. So the flows it's like that, back and forth. Okay, as long as you turn on the air conditioning system. And what happened from the AHU to the room, to the spaces? Okay, so you can see this dotted blue pipe. It gets into the AHU. So in the AHU, basically there's a fan. Okay, so the fan actually draws in air from the atmosphere, the outdoor air draws into the AHU. So just imagine that this site here is located on the external wall. So this opens up to the outdoor air. So it gets outdoor air. The outdoor air gets into the this AHU. It gets filtered. And then at the same time, basically some of the indoor air is recycled, right? Some of the indoor air is recycled, and then it get mixed up in the AHU, and then it is they passes through the cooling coil, right? The chill water pipes inside the AHU, and it gets cool, and there's another blower. Okay, blows the cool air into the spaces through the diffuser, right? So this terminal unit is basically the control system. Okay, later on, I'm going to show you like different control system available for air conditioning system. So some system you cannot control. So whatever temperature supplied from this chiller, then all the rooms will get the same temperature. Okay, sometimes you can control. You have this terminal unit where you can control the temperature so that different rooms or different spaces gets different temperature. Right. Are you guys still listening, or I've been talking to myself all this while? So I'm not sure about my connection, if it's okay or not. Guys, please respond. Guys. Hello. Rizal.
Jadi,
Okay. Takut juga ni online ni cakap-cakap seorang-seorang.
Ha?
Yelah, takut juga online ni kan tiba-tiba cakap seorang-seorang. Tak tahu line tak okay.
okay, I can hear you.
Okay, alright. Okay, so next, let's look at the each of the component one by one. So the first one, the main component of the plant system is the refrigeration plant, right? Maybe earlier I've mentioned, I've shown some example where the plant and the cooling tower are located at different location, different places, right? So maybe the plant room in the basement and then the cooling tower on the rooftop. But this is another configuration of the component. You can see here that this is the plant room. The plant room can look like just any other office building. So depending on how you design it, right? So this is another role of an architect which is to design to make the plant room look presentable, okay, to have some aesthetic rather than just looking very like a warehouse. Okay, you can have some designers. So in this case, you can see the corner window like that, just like any other office building, but it's actually a plant room. And basically, what's inside this plant room is all the components like chiller, pump, that kind of thing. Okay, so for bigger development, the number of chillers, the number of pumps required in the plant room in the refrigeration plant would be more compared to a smaller building. So that's why I believe this development is quite huge. Okay, so the plant room is quite huge as well, and it consists of many chillers inside. But you can also see from here, you can see at the back there, there's this is the cooling tower. These are the cooling towers, okay, connected to the plant room. So in this case, the refrigeration plant and the cooling towers are located just side by side, right? Okay, so the plant room can be located anywhere, but you need to consider several factors. For example, like economy of the space. I'm going to explain later on. Installation and maintenance, vibration and noise control, and so on. Right. So you cannot simply put anywhere you like, but you have to consider these factors. Okay, so please take note because I'm not sure, but probably. Not sure whether in semester 6 you are going to include plant room in your design or not. Maybe yes, maybe no, I'm not really sure. But if let's say you need to integrate, you need to incorporate a refrigeration plant, a plant room into your design. So the size, okay, the size of the room should be roughly around 5% of the total floor area of the rooms to be air conditioned. Okay, but actually the final size is determined by the mechanical M&E engineer, so they would know better the exact size required for the plant room. But at during the initial stage of design, okay, during the schematic design, you need to somehow have an indication of where you're going to put this plant room, and the size shouldn't be too small, because if it's too small and then when the M&E look at the design and then they ask you to change or to increase the size, then it would disturb your spaces. So it's good for you to consider at least 5% of the total floor area, not the whole building, just for the rooms to be air conditioned. Right? So at least the space is not going to be too small, right? And then the height ranges between 3.5 to 4.6 meter depending on the sizes of the equipment. So like I mentioned earlier, the bigger the building, the larger the building, then the size of the plant room should be bigger, and then the size of the equipment, for example, like the chill water pipes, everything would be bigger as well. So you can see from this image here, okay, the floor-to-floor height is actually quite quite high, maybe 5 or 4.65, something like that. Yeah? And then you can see the pipes. The pipes are actually not too small, the refrigeration pipe. Okay. So these drums over here basically is one is evaporator, so one is condenser. Right? So here there are 3 sets. Right? So in other developments, they would have more than that, okay, depending on the size of the development. Okay, there are 2 types of chiller used in the refrigeration plants. So this is the chiller. Basically, these 2 sets is called the chiller, the one that produces the cooling effect, right? The chiller. So the first type is water cooled chiller. The second one is air cooled chiller. Okay, so in water cooled chiller, basically the chiller is connected to a cooling tower. So basically whatever I have shown right from the start, the one with cooling tower, meaning that it is a water cooled, it is using water cooled chiller because it's connected to the cooling tower. So usually the chiller is located inside the plant room and the cooling tower outside the room. So you can see here, this is one example of the arrangement of the chillers inside the plant room. Okay, the chillers and the pump inside the plant room. Okay, so just imagine that this is like enclosed space. The grey color is the enclosed space. And then the cooling tower is located outside, maybe just on the ground like this. Okay, the reason why is because the cooling tower requires outdoor air, okay, a good flow of air from the outside, because when the fan actually rotates, okay, it would actually draws in air from the side, and then it releases back to the top, okay, to cool the water inside the cooling tower. And then you see here, you can see the pipes as well. So as already mentioned here, the chill water supply, there's chill water pipes, chill water supply, CHWS, supplied to the ASU, and then at the same time you have chill water return, CHWR, from the ASU back into the chiller. Okay, and then from the chiller, one pipe goes to the cooling tower, right? Hot water return to cooling tower, and then from the cooling tower, at the bottom of the cooling tower, basically another pipe connects back to the chiller. So basically the water inside the pipe is cooled down. After it passes through the cooling tower, it cools down, and then the water gets back to the chiller. Then from the chiller, it's get chilled. Okay, it's get chilled and then distributed back to the ASU. Examples of water cooled refrigeration plant. Okay, so can you imagine that the top part is, I mean the top image is actually a water cooled refrigeration plant. So it looks like I mentioned, so it looks like just any other office building. Okay, but because of the material, maybe material used for this building, okay, is quite transparent, so you can see the pipes inside lah. Right, so when you look at the building, you know that this is not a normal. This is not an office building because you can see the equipment behind the cladding, okay, behind the wall. But this is overseas, and then the one at the bottom is a typical plant room that normally you can see in government buildings lah. Government buildings. So usually it's located right in the middle of somewhere, okay, and then you can see clearly the cooling tower, water tank, and so on. Okay. Okay, so as an architect, I think you need to choose which one that you think you want to have, whether the one on the top or the one at the bottom. Okay, but the reality of practice, sometimes it's not as simple as that, right? sometimes the client, they don't want to spend too much on beautifying what should not be beautified. Not to say not to be beautified lah, but what they think should not be beautified lah. Just like this plant room. Okay, for them, plant room only serve. I mean, the purpose of plant room is just to produce the refrigerant, and that's it. So why should you beautify it? Right? But I think maybe for new developments like this, right? The one on top here. So you can see that some aesthetic factors taken into consideration when designing this plant room. All right, so the second type is air-cooled chiller. The difference between air-cooled chiller and water-cooled chiller. In air-cooled chiller, basically the chillers or the refrigeration plant are not connected to cooling tower. So there's no cooling tower used in this air-cooled chiller. Okay. Basically, there are two different variety lah. The first one is air-cooled chiller unit, meaning that you can see the chiller at the bottom. Okay, and then basically on top is the condenser, and then there's fan. It looks more or less like the cooling tower. Okay, but then instead of using water to cool the condenser, it uses the outdoor air, okay, to cool the condenser. So the concept is more or less similar to the package unit, to the window unit, to the split unit. Sorry. And then the second type is air-cooled condenser unit. So you can see the difference. The one on top, you can see the chiller at the bottom, but the one at the bottom, you don't see any chiller at the bottom. Basically, the chiller is somewhere else. So chiller is maybe inside the space here, and then there are pipes connecting from the chiller to the condenser. Okay. But for this one, because the chiller is there, so you don't need to provide any piping, any additional pipes to connect between these two components. So for air-cooled chiller unit, which is this one that I mentioned, no additional pipe required. But air-cooled condenser unit, you need to have pipes to connect between the chiller and this condenser unit. So from this diagram, you can see how the system works. Right? So this is chill water supplied to AHU, similar to the one before, to the water cool system. So the chill water is supplied to the AHU, and then from the AHU it gets back to the chiller, and then from this chiller, so this is where the difference is. So from the chiller, instead of connected to the cooling tower, so it is connected to this unit, to this air-cooled condenser. Okay, so the condenser is actually the coil runs inside the this thing here. So you can see the V shape is basically the condenser coil, and then as the fan rotates, right, it would actually draw air from the side. Okay, so it passes through the hot condenser coil, and it will carry the heat to the atmosphere, and the air will be released to the atmosphere, and then it carries the heat together with it. So the condenser, the water inside the condenser gets cooled down, and then it would be transferred back to the chiller. It gets chilled and then supplied back to the AHU, and the process goes on and on. Okay, so the next one is air handling unit, or AHU. Okay, so this is what's inside, more or less lah, because AHU also got some variant. So more or less, this is what's inside the AHU room. So if possible, in your assignment, so you should, if possible, try to request to look inside the AHU room so that you can see how the real AHU looks like. Okay. So the purpose of this AHU is basically to condition and circulates the air. Okay. So from here you can see the blue color pipes. This is actually the one coming from the chiller, from the plant room. Right? Number 4 is heating or cooling coil. For this purpose, we use cooling coil for air conditioning system. We use cooling coil. So this water comes from, this chill water comes from the refrigeration plant. It gets inside the AHU. So what happened inside the AHU, basically when the fan rotates, okay, sorry, here, this is actually where it starts, like number 6. Right? So when the fan here rotates, actually, I think the fan is only here, so there's only one fan. Okay, so this fan is very powerful. So when it rotates, basically it draws in, it sucks in air from, basically there's a ducting here. It carries some new air from the outside, okay, from the outdoor, and some of it are recycled from the spaces, and then it get mixed up here. It gets filtered. It gets filtered. There's a filter inside here. It gets filtered, and then number 4 it actually passes through this cooling coil, and then here it gets cool. Number 3 is vibration isolator. The purpose of this thing is basically to reduce the vibration because of the fan. Because when the fan rotates, basically it produces vibration. So if it is not treated, if there's nothing to prevent the vibration, basically the whole building will be vibrated. You can feel the vibration, right? I'm not sure. I think probably you have been in some buildings where, especially like old buildings, okay, where you can somehow feel the floor vibrating. It's probably coming from the AHU fan. And then the fan itself is located in this compartment, the fan compartment. And then at this point, the air is already cool because it's already passes through this cooling coil. Okay, and then from here it gets blown to the cool air is blown to the spaces through this ducting, okay, supply ducting. Okay, so basically it's just like it is a large metal box containing all the equipment such as blower, cooling coil, filter, temper, and so on. Okay. And the AHU can be placed in a room or exposed, depending on what kind of building that you are designing. But especially like for large building like shopping complexes or high-rise buildings, normally you have dedicated space, right, for this AHU. But for industrial building like this, yeah, maybe it's appropriate to have it exposed like this. Okay, but basically from this image, I just want to show how the ducting looks like. Okay, the ducting from the AHU to the AHU and from the AHU. Okay, this is basically the return air. The return air from the space. So just imagine that this AHU is cooling down this whole space here inside this warehouse, whatever. And then the air from inside the space gets back to this AHU. Okay, and then at the same time, this is outdoor air grill. So the air from the outside gets into this grill, and then it gets mixed up here, and then it gets filtered, and then from there it passes through the cooling coil somewhere inside here, and then the cool air or the conditioned air is blown into the spaces again through this ductwork here. Okay, so it's like it's a cyclical process, like you can say, right? Okay, so the AHU is actually equipped with switches and thermostat to control the chill water flow and temperature of the cooling coil. So this is where you control the temperature, just like the aircon that you use in your house. You can control the temperature. So for larger air conditioning systems, so you can control the temperature, but the how you control it is basically there are some variety of it. So I'm going to show you next. on how the temperature is controlled in the plant system. So for the AHU, the room size is roughly 3% of the floor area serviced by the AHU. Okay, I think you need to remember this because the basic calculation here is for plant room, the refrigeration plant is 5% of the total floor area to be air conditioned. Okay, if you have like 10 levels, then you need to calculate all the areas of these 5 to 10 levels, and then you take 5% of that for the plant room, refrigeration plant. But for the AHU, you just look into the zones or the floor level serviced by this AHU, right? So it should be 3% of the floor area or the zone serviced by the AHU. Okay, you don't look at the 5. So it's not 3% out of that 5 or 10 levels, but it's just 3% of that only one level. Okay, the next important component is the cooling tower. Okay, I've shown some images of cooling tower earlier, right? And I've explained briefly how the cooling tower works. So basically, it is a heat removal device to transfer heat from the chiller to the atmosphere. Okay, heat is removed through evaporation of water. The cooling water is pumped to the refrigeration machine where it cools the condenser coil. Right? So this is if you still remember the pipes connecting between the chiller and the cooling tower. Okay, basically there are two pipes. One pipe, basically this one that goes up here, basically supply the hot water from the condenser. Okay, it gets into the cooling tower, and then what happened inside here? So what happened inside the cooling tower is basically the water would be dripped down here. Right? It would be dripped. It actually fall down. The water falls down from the top. It falls to the bottom pan here. There's a pan at the bottom here. And as it goes down, basically this fan on top basically draws in outdoor air from the side, from this opening here, from the side. Okay, the air is getting from this side, it goes up, and it actually crosses over the falling water, which sounds like the building name. So the water is falling, and then at the same time, the outdoor air goes up. Okay, so it crosses the falling water, and it carries the heat and releases the heat to the atmosphere from the top. So that's why you can see here the steam coming up from the top of the cooling tower. Okay, so what happens is because the hot water goes down and then the air goes up, okay, it carries the steam upwards. And then at the bottom of this cooling tower, maybe you can see the pipes. I think probably the pipe is somewhere at the bottom, or maybe somewhere at the back there. Okay, so it carries the cold water back to the chiller. Okay, so you can see here the two pipes. One on the left goes up, so this is the hot water pipe. So the one on the right is basically the cool water pipes. Okay, so a cooling tower needs to be connected to a water tank to replace the water lost by evaporation. So in some cases, you can see the water tank located maybe sometimes just next to it. So I think probably here you can see the blue colored one. That one could probably the water the water tank. Okay, usually placed on high location or open space to get optimum ventilation. So that's why in some cases, as what I've shown earlier, the refrigeration plant is located in the basement, but it's not possible to put the cooling tower in the basement because it requires optimum ventilation. So that's why the cooling tower is placed on the rooftop, especially for high-rise building or a building in the urban areas where the land that the land is scarce, right? You cannot simply put the cooling tower on the ground, so you should put it on the rooftop. But if you have ample space on the ground, by all means you should put the cooling tower next to the plant room. So I believe the one on the left here is the plant room itself, the refrigeration plant, the plant room. So you can minimize the length of this pipe, right? Okay, so this is what I'm trying to explain. I was trying to explain earlier. So this is hot water from the condenser or from the chiller. Okay, so basically it gets sprayed down from the top. And then you can see the green color arrow is basically the water. At the same time, the dry cool air is drawn from the opening at the bottom of the cooling tower. It goes up because of this fan. Okay, so this is where I mentioned that it crosses with the water, so it carries the steam, okay, and releases the steam outside to the atmosphere, and then as a result, the water gets cool, okay, and then it is collected at the inside the pan at the bottom of the cooling tower, and then it is carried back to the chiller. Okay, plant systems and control methods. So basically, there are several system and several control method that can be used in the plant system. Okay, so basically there are three systems of plant air conditioning, okay, based on how conditioned air is transferred or how the refrigerant is carried to a room. The first type is all air system. So all air system basically only using air or using ductwork to distribute conditioned air from the AHU to the room. Okay, and then the second one is all water system, only using pipes to deliver chill water to the control unit in the room. So there's no ductwork, right, from the plant room or from the AHU to the rooms. Okay, and then the last one is air and water system. Basically, you have both. You have both ductwork to distribute conditioned air from the AHU and also pipes to deliver chill water to the control unit in a room. So the control method varies depending on the system use. Okay, so the most common method is basically the all air system, right? So in all air system, the control method varies depending on the equipment of the air conditioning system. So the first one is single zone. So the single zone, you can see the diagram here. So this is more suitable for a smaller space, not to say smaller space, maybe one single large space. Okay, but you don't need different temperature in the space, because for single zone system, the constant temperature will be served to all spaces. So meaning that, let's say the temperature is set at 20 degrees Celsius. Okay, so all the whole space would get 20 degrees Celsius. Okay, you cannot control, like maybe this place here you want to have 20, and then the other rooms you want to have 20, 25. It doesn't happen. Okay, it doesn't work that way. So in single zone, basically all the spaces gets the same temperature. The second one is variable airflow, using dampers to control the amount of air. So you can see between these two diagrams here, basically the component is the same, like with just the ductwork, but the difference is actually the introduction of this damper. Okay, the damper, if you still remember in last week, right, the fire damper in the mechanical ventilation system, basically it looks like louvers or blades inside this compartment here to control the amount of air transferred to the room. Right? Okay, so basically in this case the temperature is the same. The temperature is the same, but you can control the amount of airflow, meaning that for this single zone system, you cannot control the airflow, you cannot control the temperature. So so all the spaces get the same temperature, gets the same amount of airflow. But for this variable airflow system, you can control each of the, or maybe like several units of the diffuser. So like certain area, maybe you want the airflow to be slower or to be lesser compared to the other part of the space. So you can do that, right? But the temperature is basically the same. It's just that the amount of airflow, okay? So it can be controlled. So the third one is terminal reheat, using hot water reheat coils to adjust the air temperature. So in this system, basically, there is an introduction of these hot water pipes. Right? So because of the hot water pipes, basically the temperature of the air can be controlled. Okay, depending on the number of the reheat terminal. Okay, maybe you have this reheat terminal at a few different places. So maybe this one, you adjust the temperature for 20. So that the reheat terminal will basically proportion the water, so that the hot water, so that it gets to 20 degrees, and maybe that the other part of the space using the terminal reheat to actually get the temperature of 24. Okay, so the hot water inside this reheat coils, right, would actually be proportional to get that kind of temperature. And then the last one is double duct system. So this is very different from the other three system, where you have two duct works, okay, hot and cold water, cold air pipes. Basically, these are duct works. Hot air ducts and cool air ducting. So I believe this is more for overseas where I mean that they have like 4 seasons, right? Okay, during winter, during summer. So that's why they are using this kind of system. Okay, this hot air is actually coming from the outside. The hot air from the outside, okay, gets proportion with the cold air from the issue. It gets mixed up in this mixing box to get to the desired temperature. Okay, for all water system, there's only one control method for this. Okay, as I mentioned, for all water system, there is no ductwork connecting from the issue to the spaces, but actually the chill water is directly delivered to the spaces, okay, into the this device called the fan coil unit. So this fan coil unit, basically here you can see the pipes, right? So this is chill water pipes, okay, from the chiller directly delivered to the spaces. Then what happened in the space, basically, it gets proportion between the chill water and hot water to get to the desired temperature, right? So what's inside the fan coil unit is basically the fan. So just like if you remember earlier, I mentioned about the ductless package unit. So it looks more or less like that, lah. Okay, but the difference is there's no chiller inside the room. Okay, but the chill water is supplied from the chiller. Okay, and then what's inside the fan coil unit is basically just a fan. So the fan blows over the evaporator, over the chill water pipes, and the cooling effect is produced, and then the existing air inside the room is drawn in back to the fan coil terminal. At the same time, new air, outdoor air, is introduced, okay, from the opening on the side. Okay, and then this is the one that you normally see, the system that you normally see in the hotel rooms. Okay, if you have been to a hotel room, right? So you would notice that most of the time the aircon is located right above the doorway lah. Okay, so you enter from the corridor. So this is the doorway, and if you notice the ceiling height right, at the doorway is usually lower compared to the above the bed. It's because of the fan coil unit is located inside the ceiling space, okay, above the doorway. And what you can see is basically the diffuser located on the side of the ceiling. Okay, the last one is air and water system. This is where both the cool air as well as the chill water pipes serves the room, right? But again, I believe this system is more for overseas, right? So I'm not going to explain much about this. Okay, factors to be considered when choosing the most suitable system. So there are many factors to be considered. I've mentioned here 5. Okay, is there more? Okay, 5 system. But of course, because when you build a building, basically it depends on the client. Okay, but that's the role of the consultant, is basically to consult, to advise the client on so that the client would make the good decision. Of course, when you design a building, it's not going to use your money to build the building, but it's the client's money. So it doesn't matter what the client wants. It's not your money, right? So you shouldn't have that mentality. But if possible, unless the client is a very hard-headed person, so maybe very hard to convince, then if possible, try to convince the client to choose the most appropriate or the most suitable system. Okay, but then for technical things like this, like aircon, electrical, like the field services system, so normally they would just leave it to the consultant, especially the M&E consultant. Even for architect also, maybe your say in this kind of services systems are not that much compared to the engineers, right? But when it comes to the design, when it comes to integrating the system with your design, then that's where your role is very important. Okay, so the factors to be considered when choosing the most suitable system, the first one is capital and maintenance costs. Okay, again, it depends on the client. Some clients they have a huge amount of money, right? So they have a lot of money, so they have the capital to to choose the more sophisticated system. Then okay lah. But some client, they don't have that much capital, so in the end they might settle for a cheaper version or cheaper option. Okay, but sometimes even if it costs cheaper, in the long run it will cost more for the maintenance, right? Then the second one is building function. The type of system is actually dependent on the function of the building. Okay, which includes the period of occupancy for each room, type of activity, and any special requirements such as maximum humidity level, maximum temperature, air purity level, and so on. Okay, because like some air conditioning system where, like I mentioned, the single zone system where constant temperature is supplied to all the spaces, but maybe some spaces they don't require to be air conditioned all the time, right? So that's why control method is important. So you need to know what type of building to be used with what kind of control system. But again, the M&E engineer would advise on this. So efficiency of service. This is especially for buildings with special requirement. Building layout and planning. Okay, I believe this is where your role as an architect is very important. So you need to consider the distribution of zoning areas inside the building and suitability of the system to be used. Like I mentioned, for example, like the simplest example is the placement of the AHU room. So whether you want to do it by level, so 2 levels is considered as one zone, or maybe you go by wings. So this wing, one zone, that wing, another zone. But again, it depends on the type of building that you are designing. And economy of space. Okay, so as an architect, I believe economic factor is very important, right? For example, like several rooms can share the same equipment and air distribution system, and basically the placement of this air conditioning components also relates to the economy of space. Is it economical to put the refrigeration plant on the ground? So things like that. Okay, last one, the last system. Basically, this is like the extended version of the plant system, right? This is considered as the same as plant system, but the size of it makes it slightly different. But how it works is more or less similar to the plant system, and the components, the equipment involved is more or less similar to the normal plant system. Okay, so let's look at the district cooling system, or in short, we call it DCS. So it is the most sophisticated air conditioning system due to its sheer size and complexity, right? The system distributes chill water or other media, for example, gas, to multiple buildings for air conditioning or other uses. If you remember, I mentioned earlier, the plant system is normally used for one large building, or like development with multiple blocks of building. And like even like in tailors also they use plant system. You can see like tailors have several blocks, right? Academic blocks and commercial blocks. But it is considered as one entity, I would say, one complex. Okay, one building complex. Okay, the whole building is tailors. Okay, the whole blocks belong to tailors. Okay, so it's one complex. So it's more suitable to use the plant system. But in this DCS, or district cooling system, the concept is similar. It's just that instead of different blocks of building under the same complex, it is actually different. You just imagine, if you look at this diagram, you can see like this one block is like one high rise, another high rise, another high rise. So 3, 4, or 5 different high rise building served by that district cooling system. Okay, so in principle, basically it's the same. The concept is the same as plant system. It's just that the size is different. Okay, but for plant system, normally, like just imagine at the bottom here is the plant room, and then from the plant room it connects to the AHU. Okay, AHU, and then from the AHU it gets to the spaces, right? But for the district cooling system, the plant room is actually outside. It's quite big. Okay, it's huge. No? It's huge. It's separated from the building tower, from the blocks. Okay, so what's inside the block is basically what we call as a customer station. So like maybe a smaller version of the plant room. Okay, and then from there it connects to the AHU, right? And then the rest are similar. Right, but so in this system, so you can see the chill water supply, chill water return. In some places, especially overseas, they have hot water supply, hot water return, things like that. Okay, but the rest are all more or less similar. So the district heating or cooling plant in Malaysia, we only use normally district cooling plant serves as the refrigeration plant. Okay, where the chillers, where the pumps are located. Okay, the DCS consists of the three primary components: the central plant, the distribution network, right? This is the most important thing, the distribution network, and the consumer system. Okay, this is the customer station, the consumer system. The central plant may include the cooling equipment, power generation, and thermal storage. Okay, the distribution of piping network is located underground. Okay, connecting from just like this. So you can see, you just imagine like this is the ground. So the pipes all travel underground from the district cooling plant to each of the building. Okay, the consumer system normally comprised of air handling unit and chilled water piping in the building. Widely used in downtown business district and institutional settings such as college campuses, depending on sometimes if the college or the university campus is too big, then maybe they use this kind of system. If not, the normal plant system. Okay, so this is the view inside the district cooling plant. You can see the sheer size of the chiller. Okay, this is the chiller, and then this is the chill water pipes. Okay, chill water supply pipe, chill water return pipe. You can see the size is very huge. Okay, so because you imagine that this chill water need to be distributed to multiple blocks of huge building, large buildings. Okay, examples of development that uses that use district cooling system in Malaysia: KLCC, okay, KL City Centre, okay, KLCC, KLIA, Uniten, Putrajaya Government Administration Centre, University Technology Petronas. Okay, so you can see the plant room is huge. Okay, and then the cooling towers, thermal storage. This is another addition for the component of the DCS, which is the thermal storage. But I'm not going to explain that further. So this is example of district cooling plant in KLIA complex. Okay, but you can see like I mentioned earlier, the plant room itself, the refrigeration plant room, might look like a normal building, like office building. Okay, even though this office building is not so nice now. Okay. This is another one, district cooling plant for KLCC development behind the KLCC Mosque. I'm not sure if this building still exists. Anyone knows? Because I believe they have made some development there. Right? I've never been to that place for such a long time. I think I'm not sure what happened there. I think probably they extended the mosque or something. So I'm not sure whether this district cooling plant still exists. But back in early 2000, okay, actually I didn't know that this is. I thought this is just a normal office building, because from outside you can see it looks like a normal office building with windows, claddings, right? But then after learning building services, then I know that behind this wall is actually not office spaces, but cooling towers, chillers, and so on, right? So it's just like disguise, okay, to conceal the unsightly look of the aircon equipment, right? Not a very clear picture, but this is how it looks like from the top. So this is the KLCC Mosque. Okay, so this is the building here, and from the top you can actually see all the cooling towers, right? And the steam, if you are lucky, then you can see the steam coming up from this level. You can see steam coming up from the top of the building. Okay, this is how district cooling plants looks like overseas. Okay, so you can see the difference between, but maybe because these are new developments, a new building, so they put into consideration in terms of the aesthetic of the district cooling plants. I think 2 or 3 of them are located in Dubai or Abu Dhabi. I think, if I'm not mistaken, this one, the first one, the second one, and also this one. I think somewhere in UAE, right? The one on top located in Hong Kong. Okay, it looks like MRT station in Malaysia, right? More or less. Okay, and then the one at the bottom, I think, is somewhere in Australia, if I'm mistaken. Okay, but maybe the nowadays, I think the clients are they're more picky in terms of the aesthetic look of the building. Okay, so that's why the design of the DCS in the recent years getting better. Right. Okay, planning method for air conditioning system. So this is for planning and selecting a system, what architect should know. First one is evaluating and choosing the most suitable system. You can suggest, right? You can suggest based on your knowledge. You can suggest what kind of system to be used, and then, but of course, the detail part will be done by the M&E engineer. Second one, providing sufficient space for placement of all AC system component. I would say this is the most important things that architect should know. The architect should do. So you need to provide sufficient space. If not, then it would mess around with your spaces, your planning later on. So that's why right from the beginning, you need to consider roughly what kind of air conditioning system to be used, and then straight away in the initial design, you already included the spaces required for that aircon component. Considering the orientation and placement of building on site. So why is this important? Because this has some relations. There's something to do with the orientation of the building, right? So you shouldn't have your opening too much opening on the east and west side, right? Where it gets the direct sunlight, because it would actually increase the cooling load. So the rooms get hotter compared to if you place your opening on the north and east. So when the rooms get hotter, then you need more. You need to use more aircon. Okay? As an architect, by right, you should try to reduce the dependency on using air conditioning system. Of course, it's I would say it's nowadays it's a must to have air conditioning system, right? But try to reduce the dependency on the aircon. D, determining the quantity and location of the AC system component and its effect on the appearance of the building, right? So this is in terms of aesthetic, facade design, your elevation design, things like that. B basically is on the plan, spaces on plan, how you arrange your floor plan. But D is more on the elevation, so how it looks from the outside, the appearance of the building. E, considering the economic factor. Okay, depending on the client budget, what is the most suitable system, air conditioning system. And F is minimizing the noise caused by the equipment through planning and design. As an architect, what you can do to minimize the noise is basically to consider a proper placement of the equipment. So you shouldn't put the equipment in the public area. So you should tuck it away far from the public area. So that's why, as I mentioned earlier, the zones are important. So you should put all the equipment in the service zone. Selecting the most appropriate and practical AC. So this is basically the explanation of all these 6 points. Okay. Selecting the most appropriate and practical air conditioning system is basically determined by the activities, size of space, type of organization, period of use, control method, and special requirement. And there may be more than one system required in building to serve different function and requirement. Okay. So what I'm trying to show here is basically, even though the building looks the same, but just imagine that if the functions of the building is different. So the first one is, if let's say the building consists of office and shopping mall, so basically the tower consists of the office tower, and then the podium part consists of the shopping mall, right? So for office tower, you might want to use, of course, in both building, you're going to use the plant system, but you need to decide where to put the refrigeration plant. Is it in the basement or is it here? But what I'm trying to say is the control method lah. So you have learned about the control method earlier. So for office tower, is it going to use the terminal reheat method, or what the damper, things like that? Okay, because it's office tower, so it's not, is normally the whole floor would have the same temperature. Okay, and then it can be turned on, turned off, turn on during the office hour, and then after office hour it can be turned off individually, according to individual level. And then shopping mall, maybe for shopping mall you don't need to control the temperature, so you can use the first method, the control method, which is the single zone system, where you can provide constant temperature for the whole shopping mall, right? Because you don't need to control the temperature, right? So basically it's like that. But if the building is actually, the building serves as a hotel, then just imagine that the tower block consists of hotel rooms. And then at the podium level, you have the conference room, and then you have restaurant. So maybe for the restaurant, yes, you don't need to control, so you can use the single zone method. So inside the restaurant, the temperature will be the same for the whole space. But for the conference, normally in a hotel room, in the hotel, you have several conference rooms, right? So you need to be able to control each room, because not all the conference room will be used at the same time. Okay, so maybe you should be able to turn on and off the aircon for each of the conference rooms independently. And then when it comes to the hotel rooms, as I mentioned, normally in a hotel room, you use the fan coil unit. Okay, you don't use the air conditioning, the ductworks, okay, to supply cool air from the AHU to the spaces. But instead, use chill water pipes and then connect to each of the hotel rooms. Then the system is different already. Okay, so you need to decide on that, which one is the most practical. And then sufficient space. As an architect, you need to make sure that there are sufficient spaces for air conditioning system in your design. Okay, that's why you need to understand the concept and arrangement of air conditioning system component. For example, like what I'm trying to show in this floor plan is the position of the AHU, right? So actually, this is a floor plan of an office tower, of a high-rise building, office tower. Okay, so for each, I believe for each of the floor, there's one AHU serving only that level. So you can see the AHU here, right? And you can see how the AHU is integrated in the service compartment, in the service zone of the basically is the maybe some of you have heard this, the term is called core, core of the tower block, okay, where the lifts lobby is, where sometimes the toilet is also located at the core. Okay, and also the risers and everything, right? So you need to make sure that the issue is sufficient. I mean, the size of the issue is sufficient, right? And how do you arrange? Basically, the design of the core is the role of an architect. So how do you design the core nicely so that it would optimize the use of space? All right. Usually the spaces are the plant room, AHU room, risers, and spaces for ductwork. So if you have ductwork, similar to the mechanical ventilation system, if you use ductwork, so as an architect, you need to decide whether to expose the ductwork or whether to conceal the ductwork. And then the height of the floor-to-floor height, is it sufficient? If you have ductwork, is it going to be too low for people? So that kind of things that need to be considered as an architect. Circulation space around the equipment for maintenance purpose should also be provided. So as you can see from the images I've shown earlier, the AHU itself is not that big, right? It's not that big, but you shouldn't design the AHU room just nice to fit the the issue unit itself. Okay, so you need to have some space to allow for maintenance around the issue unit. Planning for orientation and placement of building on site. So individual system, for example, like unitary and package type, are more suitable for development with several small buildings on a single site, like resort and chalet. So I'm just showing like a chalet, example of a chalet where you can see the individual aircon, split unit aircon, right, is introduced for each of the chalet unit. Okay, but what I don't like in this design, like what I mentioned last week, the split unit, the aircon system is not integrated into the facade, integrated into the design. Okay, so I believe at the beginning the architect design from the elevation, it looks nice lah without the aircon condenser, right? So you only see the the balcony, the window, everything. But after the building is completed, then the client introduced the split unit aircon, so you can see the condenser. So as an architect, this is among the things that you need to consider right from the beginning. So you need to think in advance that if, say, even though at the point of time when the building is constructed, maybe the client, they don't want to have aircon yet at that point, but as an architect, you should think ahead of your client. So you need to think of the possibility of whether maybe in the future they want to install aircon. So where can they put the condenser unit so that it doesn't actually spoil your nice elevation, right? Okay, central system is more common in larger single and high-rise building, and then orientation of building towards sunlight. So I've explained about this earlier. Location of AC system components should not interfere with other activities on site. One thing good about this is it doesn't, the placement of this condenser unit, outdoor unit, is basically it doesn't interfere with activities on site. Okay, because of the placement is like that, so there's no activities right, happening on that side of the chalet unit. Okay, it's just that when you put the condenser very close to the window, basically the heat from the condenser can get into the I mean it can actually warm the window lah, make it a bit hotter lah, especially at the window area. So it effects on the appearance of a building. On the exterior, what you should consider, so how to conceal or expose the components to achieve a certain design effect. What I'm trying to show here is basically this building over here, the DCS, the district cooling system, where you actually make it look like a normal office building instead of showing its true color, showing the cooling tower, everything, right? So this is a good way to conceal the aircon equipment. Where to place the component that requires special needs, for example, like cooling tower, as I mentioned, should be placed at open spaces, right? So that's where you need to decide. So in office tower block, where you don't have much land area, so that's why you need to put it on the rooftop, things like that. So how to get the best placement or arrangement of smaller system? Okay. Yeah, so it's again similar lah. So where you want to put the outdoor unit and things like that. And on the interior, as I already mentioned, you should decide whether to conceal or to expose the piping, ductwork, indoor unit, and so on. Economic factor, this is more towards the client, so you can just advise them, right? I have explained this earlier, okay, on the client's budget, things like that. Noise, what you can do, and I think this is more for mechanical. What you can do as an architect is basically to this one, the second one, the isolating the equipment, which cause the noise from user area during the design and planning stage. So this is what I mentioned earlier about zoning, right? So service zone, because you know that the air conditioning system produces noise, okay, from the pump, from the fan. It also causes vibration. So you need to tuck them away if possible, as far as possible from the public area, okay, during the design and planning stage. And technically, you can install insulation panel in the equipment room, right, on the wall, okay, on the floor, and also separating the equipment from the floor. For example, like using like this spring like this to absorb the vibration, and also using cork or rubber sheet, okay, to absorb the vibration. Okay, planning for the placement of aircon machine rooms. These machine rooms is basically the refrigeration plant. The refrigeration plant, the main component, the refrigeration plant, issue, and the cooling tower. Okay. Okay, so let's look at the refrigeration plant, where to put the refrigeration plant. You can put it anywhere, but you have to consider the advantages and disadvantages. First one, if let's say you want to put the plant room, everything like plant room, cooling tower on the rooftop. So you can do that, but the advantages is basically there's no wastage on primary spaces, which normally found on the ground floor. So as you know, like on the ground floor, especially if, for commercial building, right? So the rental rate is much higher compared to the top floor. Okay, and the spaces are bigger on the ground floor. So you shouldn't put your refrigeration plant on the ground floor as much as possible. And then the line of piping from the cooling tower to the plant room can be reduced if both are placed on the rooftop. So normally that's the case. Like if you have the refrigeration plant on the rooftop, then the cooling tower is also on the rooftop. Okay, just next to each other. And another plus point for this placement is excellent ventilation. Okay, especially for the cooling tower. Right? Disadvantages: increased loading on the building structure, because the plant room, the machineries are quite heavy. Okay, by right, because right now you guys don't learn building structure anymore. But the logic is for normal building structure, basically the bottom part of the column should be, stronger. Like it would carry the most weight compared to the top, right? Especially if there's nothing on top, there's no plant room, so the top part would be lighter compared to the bottom, because at the bottom the column needs to carry all the load from the upper levels. But if you put the refrigeration plant on the rooftop, then automatically the rooftop becomes heavy. Then the structure needs to be very strong, right from the top until the bottom. Okay, so the columns at the bottom needs to be much more stronger. And then noise generated by the vibration of equipment. Okay, so it might be felt by all the spaces, right, the vibration. So that's why it's very important for you to use or to introduce the devices to absorb the noise. And problem during maintenance, it's very difficult to go up there to maintain, especially there's malfunction of cooling tower, replacement of chiller, and so on. It can also be placed on the intermediate floor level. We are talking about refrigeration plant. It's not the cooling tower. As I mentioned, the cooling tower cannot be placed in that position. Okay. So advantages: less wastage on primary spaces, similar to the rooftop. The length of piping from the cooling tower to the plant room can be reduced if both are placed on the same level. But if the block is like this, it's not possible. So unless if the intermediate floor is bigger like this, then maybe it's still possible to have cooling tower. Good ventilation and easy zoning for distribution, right? So just imagine you have the refrigeration plant in the middle. So you can have upper zone and lower zone, and you can have different control for different zone. Disadvantages, more or less similar to the rooftop, noise and vibration problem. and also increase loading on the building structure, but not as much as the as if you place the refrigeration plant on the rooftop. Then ground floor level advantages: easy maintenance and replacement of equipment, reduced loading on the building structure. So this is the one I mentioned, because the top floor is not that heavy, so you don't need to have a very strong column from the ground up to the top, okay, because the plant is located at the bottom here. So in terms of the cost for structure, of maybe the size of the columns can be slightly reduced, right? So that would be the plus point. The plant room and cooling tower can be isolated from the building or user space to minimize noise problem. So you can tuck away this refrigeration plant, if possible, far away from the public place, right? But disadvantages is, the main one is the wastage on primary spaces. Like I mentioned earlier, higher rental rate. So instead of placing the refrigeration plant on the ground floor, that similar place can be leased out, okay, to a tenant or something. Increased length of piping if the cooling tower is located on the rooftop. So you just imagine your refrigeration plant is on the ground and your cooling tower is on the rooftop, right? So the piping is very long. Okay, ventilation problem if the cooling tower is located on the ground floor. Okay. Basement level, less wastage on primary space, because the primary space is on the ground level, not on the basement. Reduced loading, okay, similar to if you place it on the ground floor. Easy maintenance, okay, similar. Noise and vibration problem can be minimized, also similar. Disadvantages also similar to if you place on the ground, increased length of piping. But another negative point, disadvantages of this placement is if let's say the basement floods, right? Flooded with water, then maybe would cause damage to the equipment. Okay. And then it will reduce parking spaces. So as a result, maybe you need to dig more levels, more basement level to provide for the parking spaces. And mechanical ventilation should be utilized for the plant room because there's no natural ventilation. So other possible location, depending on the type of development, the type of building, you can put the refrigeration plant far away from the building or user spaces so that you can reduce the noise and vibration and easy supply of water, excellent ventilation, and easy maintenance. AHU room also can cause noise and vibration problem. So factors to be considered when planning for AHU room. As I already mentioned, it normally located close to services or noisy zone for easy maintenance. Okay, and then you should get supply of fresh air directly or via ductwork. As you can see here, the location is in the middle of the building, so there's no way it can get direct supply of fresh air from the window. So you need to introduce ductwork to get fresh air from the outside. Try to avoid placing an AHU room next to a toilet. The reason why is because, as you know, the AHU actually, it draws in air from the outside. So if the window, if the toilet window is next to the AHU, then all the smell from the toilet would get into the inlet. Okay, it would get into the AHU, right? So it should be stacked on top of one another in high-rise building for easy distribution of piping system, right? For example, like this is a floor plan of office tower. Right? So at this level, you have 2 AHU rooms, okay, and then at the lower level or upper level, you have another 2 AHU rooms, okay, at the same place. So basically, at every level, you would have AHU rooms. It should be placed next to the rooms to be air conditioned to reduce the length of ductwork. Okay. The reason why there are 2 AHU rooms in this drawing is basically it serves 2 different zones. So maybe just imagine that in the office tower, right? So it can be divided into 2 parts. So the right wing, maybe a different office or different department, different unit. So the left wing is different department or different unit. So so this AHU only serves the left wing, and then this issue only serve the right wing, right? So that's why you need to have two different issue. Cooling tower, you should get excellent ventilation to remove heat, usually placed at an open or unobstructed space. However, it can be concealed with screening using aluminium louvers and so on. Possible location, as you can see here, this is the aluminium louvers. So from outside, you don't see this thing. So possible location of the the cooling tower. First on the rooftop, so you can see the image here. So the yellow color basically highlights the position of the cooling tower. So in many blocks, many office towers, they actually put the cooling tower on the rooftop because of the scarcity of land, because there's no you cannot put it on the ground. So in the end, you have like it or not, you have to put it on the rooftop. But as you can see from this block, the biggest block here, you can see the cooling tower from the top, but then from the elevation, okay, from below you don't see it because what, even from the elevation that you draw, okay, you don't see the cooling tower because of the screening, right? So actually at this part here there are screens to conceal the cooling tower. Advantages: excellent ventilation, no wastage on primary spaces, unsightly outlook can be reduced. But disadvantages: problem during maintenance and replacement of equipment. So you just imagine that if one of the cooling tower breaks down, so how to bring down that thing, okay? And then increased loading of the building structure, just like the refrigeration plant, and the vibration problem. So podium level, here the one indicated in red here, you can put the cooling tower there as well. Advantages: excellent ventilation because it's open space there. Less wastage on primary spaces because it's not on the ground. Disadvantages: poor outlook if the podium level is viewed from the upper floor of the tower. So just imagine, right, your office is here, okay, next to this podium level here. So you can see the top of the cooling tower, which is not nice to see, right? And then another problem is the heat from the cooling tower will rise upward, which causes extra heat load to the tower. So because the cooling tower releases the steam, so basically the steam will actually hit the window here, which it will increase the cooling load. Right. So basically this is one example of a building. I think this is in Singapore, where the cooling tower is placed somewhere at this level, which is the podium level. On the ground level, advantages: easy maintenance, replacement of equipment, reduced loading on the building structure. The cooling tower can be placed far from the building, but like I said earlier, depending on how much land that you have to put it on the ground. Disadvantages: if it's not located properly, then wastage on primary spaces might happen. Okay, the surroundings can be hotter due to the heat released from the cooling tower and unsightly view and noise problem. Okay, so if it is right in the middle of the city, then maybe it's not suitable, right? But if it's in the like a complex development, like in Taylor's, do you know where the cooling tower in Taylor's are located? Okay, basically it's in block B, right, next to the where you wait for the bus, near the parking. This the second guardhouse. Okay, so yeah, that's all for today. Just like last week, so after this lecture, you need to go to Times for the tutorial. You need to answer some questions, and then you need to submit by Friday. You need to submit by Friday through the link provided on Times. Okay, so this would serve as your tutorial attendance. Okay, for those who didn't submit the last tutorial, we have marked your attendance as absent, right? Okay, Rizal, anything else you want to say?
Okay, guys. For your case study, the building that you want to get for your for the assignment. So please make sure it is within Selangor and KL do not go to Putrajaya. It will be difficult lah for you to. The process is quite difficult lah. Get letters, you have to go to the police station.